Hello students, welcome to your classical mechanics class. In this lecture we will discuss about the homogeneity of flow of time and we will see how it leads to the law of conservation of energy. So we consider a two-particle system having two particles, 1 and 2 having masses m1 and m2 located at distance x1 and x2 with respect to origin O. Particle 2 having mass m2, x1 is the distance of the particles from the origin O. Let it be y axis, this is x axis. In general, the gravitational potential energy of a system of two particles may be a function of their positions x1, x2 and time t. So we will write the potential energy U is a function of x1, x2 and t. So the derivative of this potential energy dU is curl U upon curl x1 dx1 plus curl U upon curl x2 dx2 plus du upon dt curl U upon curl t. So as we know about the homogeneity of flow of time. This homogeneity of flow of time means that the intrinsic properties of the space do not change with time, or we can say that do not depend upon time explicitly. So in other words, if the interacting force between the two particles does not depend upon time, then the potential energy of the system will not change. So we will write curl U upon curl T equal to 0. So we will substitute this. Where from this? This is coming from the homogeneity of flow of time, which means that the intrinsic property of the space does not change with time, or we can say that if the force of interaction between the two particles is not dependent upon time, then the potential energy of the system is not a function of time. So I write curl U upon curl T equal to 0. If I substitute this value in this equation, then du equal to curl U upon curl x1 dx1 plus curl U upon curl x2 dx2. Now divide on both sides with dt, it will be like this. So this dx1 upon dt is v1, so I will write it as curl U upon curl x1 v1 plus curl U upon curl x2 v2. So this is the velocity of second particle, this is the velocity of first particle. So we know this curl U upon curl x. We know the force in case of conservative force, or in the previous lecture we have learned that the force is the negative gradient of some scalar function. Force is negative gradient of potential. So in this case we have curl U upon curl x1. So curl U upon curl x1 is Fx21 force on 1 due to particle 2. So I write Fx21 is minus curl U upon curl x1. Similarly, we will write Fx12 is minus curl U upon curl x2. So we will substitute these two values in this equation. So it will be minus v1 Fx21 plus v2 minus Fx12. Now, what is this force? Force is F is m dv upon dt. Now we are looking for Fx component of the force 21. So it will be m1 dv1 upon dt, and similarly Fx12 is m2 dv2 upon dt. So I will write here minus common Fx as m1, this is v1 dv1 upon dt, plus m2 v2 dv2 upon dt. So we can rewrite this equation as 1 upon 2 d by dt, 1 upon 2 m1 v1 square plus d upon dt 1 upon 2 m2 v2 square. Why I write this? If I write d by dt 1 upon 2 m1 v1 square, then it will be 1 upon 2 as it is. m1 is mass of the particle, so it is constant. So derivative of v1 square is 2v1 dv1 upon dt. So 2 is cancelled with this 2. This is m1 v1 dv1 upon dt. So that's why I write this m1 dv1 upon dt as d or d2 of m1 v1 square. So we can write it as du upon dt equal to minus d by dt comma negative sign here. So this is the kinetic energy of first particle, this is the kinetic energy of second particle, T1 plus T2. So we can further rewrite this as d by dt common T1 plus T2 plus u is equal to 0. So this is 0 only if T1 plus T2 plus u is equal to constant. So what is this? T1 kinetic energy of first particle, T2 kinetic energy of second particle plus u is the potential energy of the system. That means total energy of the system is constant. So finally we started from the homogeneity of flow of time and reached to the law of conservation of energy. So we can say that the homogeneity of flow of time leads to the law of conservation of energy. Thank you for watching.